This video is on parts of the periodic table and its properties. So our periodic table has two main components to it. We have groups, which are our columns, and then periods, which are the rows. Our groups, which are the columns, we can number 1, 2, we skip the D block, 3, 4, 5, 6, 7, 8. We put those in black. Our periods, which are the rows, they go down just like our energy levels do for Bohr diagrams. So row 1, 2, 3, 4, 5, 6, and 7. You notice that the group number corresponds to their number of valence electrons. So valence electrons for group 1 have 1 valence electron. Group 2 has 2. We'll skip the transition metals. Group 3 has 3, 4 has 4, and so on. Okay. Now, if they have the same number of valence electrons, they're going to have similar properties. Okay. Because those valence electrons are the ones that do all of the reacting usually, and if they all have 1 valence electron, they're going to behave similarly. And we're going to look into that more later on. But you just need to be aware that all group 1 elements have similar properties, 2, 3, 4, 5, 6, and so on. Then another thing is our periodic table is divided into 2 other distinct groups plus a little overlap. So we have something called the staircase or the amphoteric line, which runs here. Okay. On this line, we have nonmetals to the right, I'm going to abbreviate that NM because I'm running out of room, but you should write nonmetals. And then to the left of this line are our metals. Okay. Now things that are in between or on this staircase, we call metalloids. And the metalloids consist of boron and other ones that have 2 of their square lines touching our amphoteric line. Okay. The only one that is our exception is aluminum. Aluminum is a metal. Okay. Just like your aluminum cans, they're made out of aluminum. Clearly that's a metal, not a metalloid. And we'll talk about their properties in a little bit. So we just want to add on there that our staircase line, the staircase or the amphoteric line, is this guy right here. Okay. The next thing I mentioned a little bit was my D block. We skipped it with numbering our groups. That is because our D block, they're called our transition metals. So the transition metals are going to include all of the D block here. Okay. Group 1 and 2, they're still metals, and our D block, and then everything down here underneath our line, so everything under here, these are all metals too. But we just call these our transition metals because they're transitioning from 2 valence electrons to 3 valence electrons. Then there's this place here on our periodic table. You notice on yours it might say lanthanide or actinide, or it says something with like the series start here. Our inner transition metals are the bottom 2 rows on our periodic table here. Our inner transition metals, which are these guys, these should really be placed in here. Okay. The reason that we don't make our periodic table with that section in there is it wouldn't easily fit on a piece of paper. So to make our lives easier by printing it, we put that inner transition metal groups down at the bottom. And that was also your F block, if you remember when we talked about orbitals. Okay. So let's get back to our groups and rows. We said that our groups and columns have similar properties, and because of that, we give them some special names. So group 1 are called our alkali metals. Group 2 are the alkaline earth metals. We have our transition metals in the middle, our inner transition metals, because they have similar properties too, kind of, but we're going to go then next with our 7th group are called the halogens. And group 8 we've already talked about a little bit, but these are our noble gases. Okay. So those are the different parts of the periodic table that we need to remember. We have our metals, our nonmetals, our distinct groups, and I think I forgot to write this down. We also have our metalloids. Which are the ones that are on either side of our amphoteric line, our transition metals, inner transition metals, and our periods. The next thing that we need to talk about are the different properties of metals, nonmetals, and metalloids. So if I can move all of this at once, give me 1 second. So we had our metals on the left, our nonmetals on the right, and our metalloids in the middle. When I think of my properties of my metal, I think of copper. And copper, if we think about it, copper is a solid at room temperature. It has luster, which means it's shiny. It's malleable, which means we can pound it into sheets. It's ductile, which means we can pound into thin wires. And you think of copper, we have copper wires in our homes. They conduct electricity, and if we were to melt or boil them, it'd have to be extremely high. The opposite of that are nonmetals. When I think of nonmetals, I think of like carbon dioxide. Carbon dioxide, I guess we should think of, so a nonmetal. So another nonmetal would be like neon. It's a gas. Okay, so neon is a gas at room temperature. It's non-lustrous. It's, in this case, soft. It's a gas. But other things could be really brittle, so they wouldn't be able to be pounded. They would just fracture off. They are poor conductors, so they don't conduct electricity. They have low melting and boiling points, so it means that they're liquid and gas at room temperature. And then in the middle, we have things that are called those metalloids. So I like to think of silicon, and silicon is solid at room temperature, but it's also a semiconductor. So the big thing about metalloids is we use them as semiconductors, or we use them and blend them with metals, specifically our transition metals, to make alloys. But we want to have an idea about what their properties are, and we'll explore more of these when we get into our reactions unit, but you want to have an idea of them now.